Good evening, everyone. Thank you all for coming. It's an honor to be able to speak here. So I'm Joseph, and I'm a year 3 student. And today I want to talk to you about AI research, and in particular, AI research from an undergrad's perspective. All right. So the reason why I chose this topic is because, when we talk about research, oftentimes the first thing we think about is, all right, you probably need a PhD or a master's degree to really pursue research. But I hope I can maybe change that perspective a little bit and help you all understand and maybe see that actually there is some type of AI research or just research in general that can be done at an undergrad level. So as we go along in this talk, I would like to encourage all of you to just when we go through the content, we're looking through it, just think about which part of these are things that you definitely need a PhD degree or a master's degree to be able to understand. And which of these are actually things that, maybe I don't understand it now, but with 3 to 6 months of really just focusing and studying that thing, I can actually understand it with what I've learned so far. Okay? Right. So without further ado, let's get into today's talk. So the outline of today's talk, essentially, we'll talk a little bit about what AI research is. I think different people have different perspectives about this. I'll be sharing my own perspective and my own experience. I'll be walking through what we did and how this the general AI research process with respect to what my team did. And in particular, I'll talk about what skills would you need if you want to pursue AI research in the future. All right. Afterwards, talk about what opportunities are there for undergrads, what type of programs are there if you want to sign up maybe in the next few months or maybe next year or something like that. Finally, we'll talk about what career paths there are. Right. So a little bit about myself. I'm, like I said just now, a year 3 student doing math and computer science right now. And I was part of the Odyssey program in year 1 summer. So when I was in the Odyssey program, I'm not sure how many of you received the email. If you're part of SOC, you would have received something like this last year, if this is your second year in NUS. But essentially, you'll receive an email about some summer research program at maybe next year, February. Usually it's a few months before summer. And it's a summer research program, essentially. And when I joined, it didn't even have a name. It was the second iteration of that program. So yeah, keep an eye out for this later on. I'll talk more about this in a bit. But yeah, also, recently my team published a paper about enhancing text-to-image models. And I'll talk more about that as well. So this is me at the conference, which I attended, I think, it was 2-3 weeks ago. It was in Milan, Italy. So that was quite the experience as well. Okay, so I would also like to just introduce my team as well. Unfortunately, both of them can't be here. But the team, this is not my team. I'm not the team lead for this. The team is led by PhD student Zhang Yang. It's a 3rd-year PhD student from SOC. And there's myself. And also there's another undergrad called Wei Hern. So if you look at this, it's something very interesting. We had a paper and it was published and it was accepted into a conference. And look at the 3 people. 2 out of 3 of them are actually undergrads. So I hope this can convince you that, you can actually, as undergrads, you can do solid work. And when we were doing this, we weren't even year 3. We were we just completed year 1 actually. So I hope that this sheds some light that you can actually do some solid work as an undergrad. Right. So what we did was essentially we published actually 2 papers. One of it is on, the title looks very chim. I'll explain this in a bit. But essentially, it's just text-to-image models, and this was us presenting it at the conference. We had 2 papers. The left prof was Prof. Kenji Kawaguchi, right? So a bit of background about what we did, right? So the idea is that we were working with text-to-image models. So I think most of everyone here uses ChatGPT in one way or another. So ChatGPT, what it does is that it takes in text that you provided, and it generates a textual output for you. But what text-to-image does is that, let's say you have a prompt, a bedroom with a book on the bed. You put it into some text-to-image model. One of those models are known as a diffusion model, and it outputs an image, as the name suggests. Okay, not sure how many of you have played with it. If you have access to ChatGPT, ChatGPT has something called DALL-E, so you can go play with it as well. Sometimes it generates weird images, but yeah. So we work with text-to-image models, and really, these models, a bit of understanding of how they work. How do you get, maybe you give the same prompt, you give it 10 times, how does it generate, maybe 10 different images for you? How does the image generation process even work? Well, the idea is really, it just starts with some type of, pure noise. Starts with noise, and afterwards, the AI, so this noise is like just some type of randomly selected noise, and it just tries to denoise it into an image that matches the text. Okay, so for now, don't worry about how the denoising process works. The point is that the AI tries to figure out, okay, what type of image matches your prompt, and that creativity comes from noise. But the point is that it's very interesting. This is not how humans draw. Okay, when you draw something, you sketch something, you sketch outlines and stuff like that. But here, the AI just takes in noise and then turns them into images somehow magically. Let's just say magically for now. Right? So we work with diffusion models that learn to generate images from noise. And more specifically, if you want something like more concrete, start from noise. It tries to predict what noise there is, subtract it from the noise. Now you see a little bit of a glimpse of image of like a cat. You keep on subtracting the noise and you get a very sharp and clear image. So this is how diffusion model work. Okay? Right. So yeah. Now, our team's research, what do we do? So these things already exist. We did not create a new type of models that can generate images. No, we did not do that. And later I'll tell you why you probably don't want to do that as your first research. But what we did was that we took this prompt, we generated it, and if you look at this image closely, it's a bit small if you're at the back, I'm sorry. But if you look at it, you see a bed, you see some books here, but nothing too prominent, nothing too special. But you see that, okay, I generated something, I want a book on the bed. That's not happening here. So in some sense, you can say that the AI failed. So that's what we realized, all right? The AI has some type of inaccuracies, like the diffusion model didn't really complete the task. So what we wanted to do was that, we want to try to figure out why that happened, and it turns out there's like a key insight. So don't worry about what you're looking at for now. The idea is just that there's this thing called attention. So I'm not sure how many of you heard of this thing called attention, which is it's a very crucial crucial component of how large language models work these days. Okay, the key idea is really that we talked about how diffusion models, they generate images from random noise. So it has to pay some attention, right? Like let's say for that particular token, that particular word bed, you would think that it would have an attention, like the part that it pays attention to should correspond to the position of the bed. Alright, that's what we want. And you will see that that's indeed happening for the bed. And for the book, it's paying attention in the bookcase, in the books in the bookcases. So that's actually happening. That's what we realized. This is sort of well known. This is fine. But what we observe is that there's a correlation between the attention and the object that's actually generated. So we thought, okay, let's leverage that and see what we can do about it. So we figured, all right, so we have the original. Then what we did in our approach was that, all right, let's try to just alter this artificially. Let's try to disrupt this a bit. Like the bed is nice. It has one clump of stuff here. Like at this point, it's pure noise. It's just a clump of stuff. The AI has no idea what it's supposed to look like. So why as well, let's just make it a clump of stuff. Maybe this will become a book. So that was really the intuition behind it. And we just edited it. We enforced this for the first 10 to 15 steps. And then afterwards, so you can see the editing sort of happened here. And afterwards, we let the model do the rest of the processing and try to figure out where the attention should really go and how to shape a clear image. And you can see that we did get a better result. So if you look at this, we did manage to get a bed with a book on it. So this was really this is really perhaps a 5 to 10 minute breakdown of what we did in our research. Of course, there were a lot of different paths that we could have taken and things like this that I won't explore in depth today. But the point is that I hope this gives you a better understanding of what we did in the paper. And you can see that the concept is simple. I just explained it in 5 to 10 minutes. It's really not that difficult of a concept. The only tricky bit was, I guess, trying to see that this was the insight that's required for something like this. Right. So today, now the main thing here is, I'm not here to talk about our research in depth because it's already done. People can improve on it. We can continue on it. If you're interested, you can talk to me about it after the talk. But really, what I want to talk to you about today is, all right, how does the AI research process actually look like? So with a little bit of understanding of what we did, I want to talk about what you can anticipate in the future if you want to go into AI research. So I'll talk a little bit about the process of AI research, and just caveat, this is my personal perspective. Like I said, everything here, you ask 10 different people, they might say 10 different things. But so this is really my experience for the past year, right? So when we talk about AI research or just research in general, I don't know how many of you think of it as like just people staring at whiteboards or like writing crazy math equations. Or maybe there's AI, right? So there's some coding. So you would think about, oh, there's a lot of coding involved. So maybe this is your perception of research. And I would say there's some truth to it. There's definitely math, later we'll see, and there's definitely coding. Right? But there's more to it. There's a lot more to it actually. So the research process, right? I would say I'll break it down into like 4 key components. The first one is identifying knowledge gaps. Then afterwards is this idea of formulating ideas. Then running experiments. And finally, it's about analyzing the results. Of course, there are a lot of more. You can elaborate a lot more on this. But for the purpose of today's talk, I want to just focus on these 4 steps at least. And I want to talk about how, like, as an undergrad, like, perhaps you would think like, oh, maybe this paper was hard carried by the PhD student. All right, but I'll tell you something. I did say up to 80% of the work was done by the 2 undergrads. Actually, so not to say that his contribution was not important. It's an equal contribution among the 3 of us. But in terms of like the actual work that was done, like there's a difference between the quantity of work versus like the impact of certain observations and insights, right? But I want to talk about like each of these steps and how they relate to the research process and how it related to my own experience as well, and what you can anticipate when you try to do like research in the future, right? So we'll talk about identifying knowledge gaps first, and really this leads us back to this point that I raised just now. We didn't create a new type of stable diffusion. We didn't create a new type of model to generate images. Like maybe some of you heard of like GANs, like generative adversarial networks, or like now we are using diffusion models. We didn't create a new type of model to generate images. And I say this is a very important thing to realize, which is that you have to pick your battles. So like if you're doing research as an undergrad, like you can't possibly expect to be able to do like very, very like game-changing or like really drastic things. Like you want to come up with a new ChatGPT, you want to come up with ChatGPT 5. Like, yeah, you can try, but chances are it's very difficult. All right, and not all research has to be something as bombastic as when OpenAI released ChatGPT or when we first saw diffusion models and something like that. It can be something simple, something smaller, but it contributes to like in the grand scheme of things, it contributes to our understanding of certain models. Right, so it's important to pick your battles and pick topics that are actually within reach. And the good news is, if you're doing like research as an undergrad, right? So odds are you'll be paired up with like you'll be placed in a group with perhaps PhD students and perhaps even some professors, and they would already have a direction. And in these type of programs, like for example, the Odyssey program that was part of, right? Like they would have released like proposals or even like some kind of synopsis of programs or projects that they're doing. So you can see which one you're interested in, and they're usually they've already filtered it to be such that they think that, okay, at an undergrad level, you have some things that you can contribute to the project. So I would say don't worry too much about this, but do take note that at this stage when you're doing research, you can dream big, there's nothing wrong with that, but also be pragmatic and understand that, yeah, sometimes, you have to take baby steps and build along the way, right? So in our case, we identified certain knowledge gaps. Like we realized, okay, people have created nice text-to-image models. This is a pretty nice image. Like you do this, like they showed this 5 years ago, people would be shocked that an AI generated something like this. But we realized, okay, it generated something inaccurate. So we asked questions like, do we know why the model got it wrong? Have people tried fixing this, right? And what have they tried? So for those of you who are maybe familiar with research, this would be the process of a literature review. You're looking at what other people have done. So we've looked at like different papers. I'll just highlight like a few. And here you can see that this is actually a paper published by a team in Israel, I think a few years ago. This is by a team in Korea, probably 1 to 2 years ago actually, right? So this process of literature review, it's important. Because just now we talked about how we realized there's correlation between attention and things like this. And like, of course, we knew that already. We had some background, we had some understanding of attention. But it's great to see that, other researchers have figured this out. They have seen how important attention is, and they have shown that, okay, the objects appearing actually corresponds to it. So what we decided was that, okay, based on this understanding of what other people have done, right, we can formulate some ideas. like based on these two insights, we can see that, okay, we need some way for the model to pay attention to the correct things, okay? And we also need some way to separate the attention for objects. Like if the cat and the frog's like attention in this particular case, like the first case, right? You see that like the cat and frog attention, they're sort of like intertwined, then the frog might not appear. You want them to be separate. So these are insights that you can draw from looking at what other people have done. It's not to say you're copying their work. You're not trying to make your work like 99% similar to theirs. There's no point in that. But the point is to learn lessons from what they did and try to apply to your own scenario. And what we did was that, in this case, the Korean team, what they did is that they drew like some type of like mask to put on like the attention maps to try to like increase like the attention for the corresponding objects in that area. And that turned to work out pretty well. But it's tricky, right? Like you have to draw this. This is like a bit annoying. So we figured let's try to automate this process. And for the first team in Israel, what they did was that they adjusted the attention in more nuanced way. So we figured it's a bit slower. We found a way to optimize it, make it better, make the effect stronger, and actually make it faster as well. So this is like the main difference between our work and theirs. And it's important to be able to see how your work differs from what others have done, because you have to convince people that your work is different. Okay, so yeah, that's important. Now a little bit of math, don't be scared about it. But the point is this. So when you're formulating ideas, right, like it's great that you can put this in words, but you want to test it out. You want to write it into code. You want to run experiments. You need to write a paper. You need a little bit of math. Now, that's really the point of having the math to back up this kind of research is really because you want to write code. Like you need to translate this some way into Python code that's like runnable. And the way to do that precisely is really to write out like the mathematical representation of it. So there's no getting away from it. Like AI research, later we'll talk about the skills involved, but just a bit of a precursor. You definitely need some background in math. You don't need a lot of background. You don't need a math major. You don't need to be a math major to do it. But the point is that you need some background and some understanding of it. Okay? So this is for formulating ideas. You get some ideas, and this is the part that usually takes the longest. And later we'll see that it's actually an iterative process. So if you look at this, like it's a bidirectional arrow. The point is that it's iterative. So right now, like for the purposes of this talk, you see that okay, it flows smoothly. Like we're going from here to here and next so on. But in reality, like we went back and forth quite a bit, and later I'll share more about that as well. So after you formulate your ideas, this is where it's the formulation of ideas often takes the longest because it involves getting that idea in the first place. Once you have it, this is when you really start to probe your results. Like you run some experiments, just small ones. Don't run like 10,000 samples or something. Just run small ones and try to see if this actually corresponds to what you expect. Then you do a little bit more comparison, compare with like the regular ones with the original versus what you did. Do you actually see an improvement? And then afterwards you start comparing against other approaches. Because chances are, like this is an important topic. It's not a topic that like is studied to death, but there's still a lot of teams doing it. Okay, so it's important to look at what other people have done and how your method fares against theirs, right? So this is an important step. And this is where like in reality, it wouldn't be so smooth. You wouldn't have a case where perhaps sometimes you wouldn't even have a case where your idea beats out the benchmark. Like your idea might even be worse than the original. So that's something you have to anticipate. So that's why like it's an iterative process between like analyzing your results and going back to the drawing board and trying to find like some new ideas, right? So in a way, it's a bit similar to like the software development lifecycle, which I believe most of you are familiar with. So there's a lot of like you ideate and then you try to implement it, you run some tests, see where it fails, and try to figure out how you can improve it. Okay. So finally, the final step is that when you're writing a paper, you need to compare it like quantitatively. What this means that like everything here, people can argue, oh, you cherry pick these examples and stuff like this. So make sure like it's a very important thing to like have like a robust benchmark that you can test against to show that hey, what you're doing is actually better than the state of the art. So that's like an important thing to take note of. Which don't worry, like there's a lot of points here. But the idea is that these are things that when you go into like research for the first time, you're working with like a PhD student or a prop, they will definitely notice. But this is just to help you anticipate what are some steps that are involved, and they will guide you along the way, right? So really, this is like the key flow of like the research process. And I hope like this gives you a better idea of like, yeah, there's coding, there's math, there's staring at the whiteboard, there's also a lot of discussions. So like it's a mix of a lot of things, and there's a mix of like reading papers and things like this as well. Right. So we talked about how research can look like. So I guess the natural question is, all right, we've seen what you do, what type of skills do you need to have to be able to perhaps like have a higher chance of succeeding or even thrive in this area. So once again, my personal perspective, but I would say there are sometimes some people when they think about research or like that, oh, this is a very prestigious thing. And yes, it is like it depends on how many people apply for that particular role, right? But perhaps like naturally some people think, oh, do I need qualifications like these? Or do I need to win Olympiads like these? Well, I'll tell you, I want none of them, okay? So yes, you don't necessarily need that. Or maybe you would think, oh, do I need to have taken modules like these, right? Like, do I need to have taken like really advanced AI modules to do research? Well, like I said, I did this at the end of year one summer. No way I could have taken any of these, right? So yeah, it's if you have self-studied some of these, or right now you're year 2 or year 3, you've taken some of this, amazing. Like I'm not saying that, oh, if you have done these or like you have taken these, you can't do AI research. No, like there's a plus. It's a huge plus. Like the way you think, like when you're going for like Olympiads like these, or your exposure to like formal treatment of like machine learning or AI, that's always a huge boost. But the point is that no, you don't necessarily have to view these as prerequisites. All right. Of course, it depends on the teams. Like for example, in the Odyssey program, like if you keep an eye out on the emails, last time the ones I got, like there's like a list of projects. It's like a PDF of like 10 plus pages, and each project, like the PhD student would like list out like some requirements. Some would have required you to have taken like CS 2109S. Mine did not require that, so I went for that one. And honestly, I would say that like it's not a huge requirement because later we'll talk about like what you really need to do, what you really need to have, and oftentimes like it's a good to have, but these aren't like 100% like necessities, right? And finally, do you need a lot of domain knowledge? Just now I talked about how our team worked with diffusion models like text to image. When I joined, I had no idea what text to image models are. I had no idea what diffusion models are. All right. In fact, when I joined, it was under a different topic. Like the topic that I got from my supervisor that in the PDF, it was on like explainable AI. Like that's like it's a big topic, very important topic. But afterwards, it's like, oh, my prof decided perhaps we should change direction, look at this particular topic. Are you interested? And well, thankfully I said yes. But the point is this, you don't need a huge amount of domain knowledge for you to just get into research. You need to build this up as you're researching, all right? You need to build this up. But you don't necessarily have to start with it, especially like if you're not the one leading the project, right? So now, what skills are actually needed? We saw what it may not necessarily be needed, what are actually needed. So just now, if you look at like a process between like identifying knowledge gaps and formulating ideas, I would say that some background in mathematics is needed. Of course, I'm a bit biased, I'm a math major, right? But the point is that you do need some. And later we'll see exactly where they come into play. But in terms of like AI aspects, these three are probably the most important when it comes to AI. Probability, linear algebra, and optimization. Towards the end, I'll provide some resources on where if you're interested, you can learn more about this. And in terms of like the CS side, right? Like especially like for implementing like code to like run your experiments and things like that. So definitely SWE foundation, believe it or not, software engineering skills, very important. So when we did our research, anyone wants to just make a guess? Like I did 2 projects. Let's say the bigger project for the second one. How many lines of code do you think is in the repo? Anyone wants to make a guess?
Maybe I guess 40,000.
40,000? Or
Yeah.
4? 14 or 40?
I don't want.
All right. Okay. Yes, thank you very much. The second project itself was minimally 25k line of code. Minimally. The first project was at least 15k line of code. Right. So if you have 25k line of code, you don't follow good software engineering principles, you're gonna go crazy. Okay, so very important. So that's a very important aspect to be able to work effectively. And recall, this is a team effort. Like the team doesn't just comprise of you. You're working with other people. So make sure you have a solid Swift foundation such that the code you write is readable and you can debug easily. Like one of the worst things that can happen when you're doing research is that you run your experiment for a week. And because these experiments, like they have to run on GPU. They can't just run on like a MacBook or something like that. And you run it for a week and you realize, oh, there's a bug. And then, okay, then 1 week worth of work is gone, right? So it's important to make debugging easy and have a lot of tests in the process. And that's all three principles, okay? And the next thing is practical experience with like machine learning and deep learning, right? So like, just want to talk more about it, like how you can get some of these, but if you put all of these together, right, you might wonder like, why do I need stuff like this? And I think one aspect that really brings up all of them together is that gives you the ability to learn new concepts really quickly. So this is the thing about research, which is that you're not just in your own environment doing your research and hope that, okay, you do something nice and publish and call it a day. You're looking at what other people are doing. Like sometimes like when we were researching, when we were doing like our project, like we saw like different papers like being published like the next day, and then like we read it, and you have to be able to understand them. Like these are just some of the papers that we read. Like I think I put like 6 of them here. I think across like the whole research project, we read like more than like 30 papers at this point. So each of these papers, they're dense. They are very mathematical. They're very formal. So you don't need to be able to reproduce them. You don't need to be able to like be the one to come up with the idea. But you need to be able to understand the ideas efficiently. And that really goes back to like these type of skills. If you have a strong background in these, and you have strong background in like machine learning and like deep learning in a practical sense, it helps you understand where they're coming from, helps you understand like why they're doing this, why they're doing that, and understand what they're saying. So it makes things a lot more efficient. Okay? So we talked about the skills needed, and I would say if you're looking for some resources, I recommend this to almost everyone. There's this book called Probabilistic Machine Learning. Feel free to go check it out. It's by Kevin P. Murphy from MIT. And then like if you want some practical like experience, you can always like join some hackathons and Kaggle and things like this. And believe it or not, so here's a very interesting, I'll just share a little bit of like how I got into the project. So what happened was that I think it was in like 2019, I joined a Kaggle competition with some of my friends out in JC back then. And we joined, we did something nice, we got like a decent result, and we published the code on GitHub. So when I went for the interview for this research project, like the PhD student, he didn't ask me much, he just put up my GitHub repo because it was attached to my resume. Then he just started asking me things about what we did for the competition. He started taking out bits of like my code, like, okay, explain to me what is a CNN, explain to me what is binary cross entropy, why did you do this, why did you not do that, and things like this. So the point is this, you need practical experience and make sure you document them as well, right? Documenting them and letting other people know that, hey, I've done this, I have experience in this, and actually I know my stuff. That's very important, okay? And oftentimes, like for like projects like these, they're not like official like interviews like from like big companies like TikTok or Shopee, like you have to go to HR interviews and things like this. No, you're just talking straight to like perhaps the PhD student or the professor. And it's very, they'll just go straight to things like GitHub and see what you've done, what experiences you've had, and they'll just ask you about it to see if you're fit for the team. So that's really important, okay? Right. So now we'll talk about why should you consider AI research. Like, so here's a quick note. The Odyssey program is something that happens during summer. So like let's say if you're year one, you might be considering doing orbitals at that point, right? So like for myself, I actually didn't do orbitals because I had a little bit of experience with like this type of like projects and stuff. So I decided to go into like research. But in a case like maybe you're weighing the pros and cons. Like so here's like something for you to consider when you're trying to weigh between like which one you should do. Right. So the first thing that you can, like I'll say one of the big benefits of this, in a way, it's sort of circular. Like you need to have, you need to be interested in AI and have a deeper understanding to first go into research. Obviously, I said like, okay, you don't need all those mods prerequisites, but you need to do a little bit of self-study. You need to know a little bit more. You need to at least be able to talk to people when like your interviewer asks you about like certain things about machine learning or like deep learning. You need to be able to understand them. But as you go into the research, you understand that even better. And I think in an era where ChatGPT is so powerful these days, like you wanted to build a neural network, you can write this in like less than 5 seconds. So I would say try to go beyond import torch. Okay, like oftentimes these days you say, okay, oh, I've done like a deep learning project. Really, like, yes, it's good, it's impressive, but at the same time, ChatGPT can do it. So what makes you different from ChatGPT? And I would say really is the understanding. So this is a really good opportunity to be able to like go beyond import torch and really understand what each of the components do, understand what attention modules are, what transformers are, and things like that, right? Secondly, the other thing is to learn how to systematically test out new ideas. So this, in a way, it's very applicable in research, but at the same time, it's also very applicable in like when you just go out into the workforce. So here's the thing, like just because you did research as an undergrad in NUS or like in any other school, doesn't mean you have to become a researcher in the future. But a lot of skills are actually transferable and you can carry it forward. So why do I say that it's important? It really builds this ability to like test out ideas and in particular new ideas systematically. Because if you look at like the problems that you usually solve in like modules or like perhaps like even in certain projects, a lot of these they're well-studied problems and like a lot of their optimal solutions are known. People know what to test for, they know what to look out for. But when you're doing research problems, well, some or maybe very few people have explored it, right? And the solutions are often suboptimal or even incomplete. And depending on like what field of AI, like you might think, oh, AI is such a buzzword, it's such a big field, like everyone's dumping money, everyone's like dumping resources into it. So there must be like a lot of work being done in it. Yes, but there are still parts of AI that's like very new, that's very cutting edge. That there's a lot of like sometimes the problem is so new, there's not even a good way to test it. So what do you do in those situations? And you won't find this anywhere else. This is in a way, a very research specific type of challenge, right? So I would say like this is a very unique experience as well. And finally, one of the biggest things to take away as well is that from research, you learn to communicate and understand novel ideas. And once again, this is something that you can carry along with you for the rest of your life as well. So one of the big things is that, like I said, you're coming up with new ideas. And here's the thing when you're doing research, right? Like your team will have been thinking about the problem for 3 to 6 months, and you come up with something amazing. Now you have to write an 8 pages. The paper you write maybe 8 pages long or 14 pages long, depending on what you submit it to, and you have to explain concisely to people who have never seen this idea before. You can't explain to them face to face. You have to write it down. So it's a skill to be able to communicate this effectively. And at the same time, it's not just communicating it to reviewers or like communicating in like a paper type of sense, but it's also with like communicating within your team. Like for the way our team works is that my supervisor, the PhD student, he would just like, okay, you give like a broad direction and like you say, right, you go look into like this area of stable diffusion, go try out these prompts, go test out if like this behavior exists. And afterwards, like in 1 week's time, let's have a meeting and report back. And what I really liked about what he did was that he made us present it in like slides. He always made it like prepare slides and not just have us show up like, oh, you know what, here's the code, let me open up VS Code, let me open up a few pictures from gallery, like this is the result. You can't, it's not effective. And it's important to know that even within your own team, when you're thinking about novel ideas, like you need the other person to understand. So how do you communicate it effectively, like show them the results, show it to them effectively, and like describe it to them effectively. So these are just some, like these are actual slides that we, like you don't need the slide to be very fancy or like very complicated. But the point is that you need to convey your idea effectively to the people you're talking to. And yeah, so here, like you can convey through slides, and afterwards, once again, like when things got really complicated, like that's when my supervisor actually had me like write up like a sketch of like the actual formal like definitions of how everything works to be able to like have the whole team truly understand what's going on. And that's the thing about mathematics. It's not like some of us read research papers like, oh, so cool. There's like very nice math equations in there. I have no idea what it's saying, but it just looks really cool. And the point is not to make things complicated. Like a lot of times we think that math is so complicated, why do people want this type of things? The point is that math allows you to be very precise. Like you need to communicate this idea that you came up with in your mind for like a week. You need to communicate it precisely to maybe 2 or 3 other people. Then of course you have to convey it to maybe a group of like 4 different reviewers and like things like this. You have to convey it to like the world eventually when you publish. So how do you make sure that they don't misinterpret what you're saying? It's just the only way is to do it rigorously through math. Okay, right. And the last bonus of like why you should consider research is that when your paper does get accepted, if it gets accepted to the top conference, the school will most likely fund you to attend the conference. Like the school thankfully funded my trip to Milan to attend the conference. So yeah, in a way, it's like what my supervisor said. Like the trip to attend like the conference, you can view it as like an affirmation of what you've done, and really see it as like this is like this is in a way like to congratulate you for the job well done, right? So this is an additional bonus in that. Right. So we've talked about a lot about like what research is, and before I wrap up, I'll just show a few like opportunities there within NUS. And so just now I've been talking a lot about this Odyssey program. Really just look out for it in your email. Like when I first got here, no one told me about this. Like it was just one day I was looking at my NUS email. I saw, oh, summer research program. Looked through, signed up. So here now I'm telling you, do look out for this actively if you're interested. Okay. There's a slight caveat. It might only be open to year 1 and year 2. I'm not sure if they changed the policies. Okay. But if you're year 2, if you want to do it, feel free to email them. I would say that they don't necessarily have to do it under this program. Like one of my suggestions is really you can actually cold email profs of PhD students. And if you need a list of PhD students to cold email, if you're like a year 3 or year 4, probably year 3. I think year 4 after this, like you probably have done it FYP already. But like for if you're year 3, you want to cold email some PhD students, just look at the Odyssey program list. With their emails there, go email them, right? And Europe's definitely one option as well. Yeah, but in terms of like within NUS, I think these 3 are like the in a way like within the school sort of like a more official thing. But another option that you can consider, just now Tzun said from stats data science. Recently, our CCA actually we started like our own research team as well. So we have like a group of like students. We propose like research ideas, and we get a bit of funding from the CCA. We have some guidance from the profs as well. So we look at like different topics from like different statistical analysis methods to like LLMs and like even like graph neural networks. So if you're interested, this CCA we have like recruitment like at the start of every AY. So just keep an eye out if you're interested. Right, and we also have like we probably have like a presentation in the science library area like next semester. So stay tuned for that as well. Right. So I'd say these are like some opportunities that you should definitely take note of if you're interested. Finally, right, we talked so much about this. What are some research, some career pathways for researchers, right? One of the career pathways, the default one is really you can continue as a postdoctorate researchers in the different universities, and like each university like has like their own labs. Like for example, my supervisor, he's in the deep learning lab in NUS. If you're very interested in computer vision, NTU actually has a very strong computer vision lab. Like when I was at the conference, one of their main profs there were invited to give like probably 5 different talks there. So they have a very strong computer vision program. Deep learning program, we have that in NUS. NUS also have their own like robotics lab as well. So if that's something you're interested, feel free to look it up. Right, and also you can go into research in the private sectors like ByteDance in Singapore. They're always hiring. Then there's also research positions in government agencies as well. I literally just went on LinkedIn and searched for research positions. It's that simple, okay? So yeah, these are just some of the ones that I found. All right, so that's actually the end of my talk. If you have any questions, feel free to ask. You can reach me through my email here. If not, thank you very much for having me. Any questions? Yes. If not, I think later there's like a pizza break or something, so you can always come up here. But for now, I'll just pass the time back to Jimmy. Thank you.
Thank you, Joseph, for this awesome sharing. So yeah, now we can have a break. Let's take a break until 8 p.m. and we'll come back for our second talk. On the setup.
Good to see you, Russell. Good to see you. Call you on the